We'll be talking about linear inequalities today, and hopefully we'll also get into solving systems of linear inequality statements where we have two or more variables and we are trying to find solutions to two or more inequality statements that have two or more variables. But just as a quick reminder, if I have any number line here, if I tell you that x equals 1, then I can mark a dot right here and say that that is x. Okay, if I use an inequality statement on this number line, graphing on a number line, I can tell you that y is less than 0, for example. Okay, if it's less than 0, it's going to be an open circle. So when we're graphing this on a number line, we would have an open circle at the 0. Y can be any number less than 0. Okay, so this is just graphing a number or graphing an inequality. So one more step into what we're going to be doing today. If we have some sort of an equation like this, y equals 3x plus 2, and we want to graph that information. This is a linear equation, a linear equation, and so what it's going to do is give us a line to graph, and so we could graph that line on a coordinate grid, a coordinate plane. Move all my stuff up a little bit here. If I wanted to graph a linear equation, I would say y equals 3x plus 2. I'd start here at 2, go up 1, 2, 3, and over 1, up 1, 2, 3, over 1, and make my line like this. And forgive me for not having a perfectly straight line. That is the graph of the linear equation y equals 3x plus 2. So today we're going to talk about how we graph information when we have a linear inequality instead of a linear equation. All right? So we're graphing one single point right here. Here y is less than 0. We're graphing an inequality just on a number line. And on this coordinate plane, we're graphing a linear equation because I have equal sign instead of inequality statement. So what we're going to look at today in class, this is Unit 5, Day 4. We are going to look at how to graph and represent linear inequalities. All right, so a linear inequality is similar to a linear equation, except that the equal sign is replaced by an inequality symbol. And the solution to a linear inequality is any ordered pair that would make that inequality statement true. So you'll have more than one answer generally. Okay, a linear inequality has an infinite number of possible solutions, and we'll show you how you can see those on a coordinate grid. When we want to solve a when we want to graph a linear inequality, what we're going to do is plot the boundary line. That's what we were going to call this. So we're going to imagine what line we would have if it were an equation. We're going to plot that boundary line, and then we're going to make a decision about whether we're using a dashed line or a solid line. This is similar to using an open circle or a closed circle when you're talking about inequalities. Okay, so if I come back to my inequality statement here, y is less than 0 ends up being an open circle because it can't actually include it can't actually include the 0. But if I wanted to say y is greater than or equal to 2, that would include the 2. So it could be equal to 2. So that's why we're solid circle. It could be equal to 2, but it also could be anything bigger than 2. Okay, so when we're graphing our linear inequalities, we are going to make a decision about whether we get a solid line, which means that it can include all of the points on there, or if it's an open circle idea, if it is less than and not equal to, it's going to be a dashed line to show that information. Okay, so we're going to plot a boundary line, and then we're going to make a decision about whether we have dashed or solid, and then we're going to pick a point. We're going to pick any point that's not actually on the line, see whether it works for the inequality statement, and if it does, we know that side of our boundary line is going to include all of our solutions. So let me do some examples and see if that helps you understand. Okay, all right, I have y is greater than 1/3 x minus 5, and so what I'm going to do, This is already in slope-intercept form. Remember, that's y equals mx plus b if we're talking about an equation. And so I have a y-intercept, and I have a slope that I'm going to use. So I'm going to plot this boundary line. I'm going to start at -5. -5 right there. Okay, my slope is 1/3, so I'm going to go up 1/3, up 1/3. I'm going to back myself back. And so that line is going to follow those dots. Okay, so we're going to plot our boundary line, and I have to make a decision before I draw my line. Is it a solid line? Can it include everything that's actually on the line, or is it a dashed line? This time, I do not have an equal sign anywhere in this statement, so it's only going to be a dashed line. Okay, my slope was 1/3, my y-intercept was -5. Okay, I'm going to use a dashed line. So when I do this, I'm going to use my ruler or another pen or a piece of paper or something. I will tell you this is a place where you're going to find that I make mistakes, and so it's hard to turn a solid line back into a dashed line. Get all creative with that. So just be careful, try to pay attention, but it happens if you accidentally draw a solid line. Okay, so I have drawn the boundary line, and now I have to make a decision about where I'm going to shade this graph, this coordinate plane. So I'm going to choose a test point. I'm just going to choose any x and y combination that I'm willing to work with. My test point is going to be 0, 0, because I love zeros, because they're really easy to work with, as long as I'm not dividing by them, okay? So I'm going to test with 0, 0. That means x would be 0 and y would be 0. I'm going to just plug that into my original inequality statement. If I plug in 0, 0, then I would get 0 is greater than 1/3 times 0 minus 5. 0 is greater than -5. Is that true? It is. This is true, and so that means my point 0, 0 is one of these solutions. So 0, 0 would be one of the solutions. So any one of these points over here would be one of the solutions. So just for fun, let's pick one. So if I had 6, 2 as another test point, I'm just going to show you that it really does work. If I have 6, 2 as my test point, and I plug that in, y is 2. Is that greater than 1/3 times 6? I'll write that at 6 over 1 minus 5. So I have 2 is greater than 6/3 is really 2. 2 minus 5. 2 is greater than -3. That is true. So this point also works, right? So really, I promise all of the points that are on this side of my dashed line, my dashed boundary line, are possible solutions. You could choose any one of these points, plug it in, and it would be true. All right, so that's how we're going to graph any linear inequality. We graph our boundary line, we decide whether it's dashed or solid, and then we use a test point. Okay? You'll notice maybe eventually that if you have a statement that says y is greater or greater than or equal to the rest of the expression, then you are going to be on the upper part of your boundary line. If you have y is less than the rest of the equation, the rest of the inequality statement, you're going to be below your line. But it's always safest to choose a test point. Don't choose a point that's actually on the line, though.